Every now and then, we're forced to take absolutely everything we thought we knew about our world and just turn it completely upside down. So, pull up a chair. Today, we're going on a bit of a mind-bending journey into a truly radical idea called the Small Bang Theory. It's this fascinating concept that actually offers a single, unified explanation for, well, the whole shebang. Our moon, the oceans, the continents, and, yep, even those massive extinction events. Let's just dive right into it, shall we? Earlier, you looked up at me with these huge, curious eyes and asked, Professor, why do scientists sometimes have to completely rethink how the entire world works? And honestly, that is just a brilliant question. Think about giants like Charles Darwin or Albert Einstein. Sometimes scientific progress isn't just about digging up new data. It's about shattering those old, stubborn dogmas so we can finally see the obvious truth that's been hiding in plain sight the entire time. Oftentimes, all the puzzle pieces are already sitting right there on the table. We just need to look at a completely different picture on the box to figure out how they actually fit together.
So let's rewind the clock way, way back. About 4.6 billion years ago, our planetary home was literally just an incredibly hot, glowing, molten sphere. And for billions of years, it just slowly cooled down in this very quiet, linear sort of way. By about 541 million years ago, a completely sealed, solid granite crust had formed all the way around it, and the Earth just sat there, quiet as a mouse, for hundreds of millions of years. That is, until a sudden, massive disruption exactly 66 million years ago. We call this the Small Bang. And it was the single cataclysmic moment that actually birthed the blue planet we live on today.
Just picture this visual transformation in your head, because it's wild. Before 66 million years ago, the Earth was essentially a dull, gray, completely sealed granite ball. It was covered in these shallow, stagnant swamps, nothing deeper than maybe 500 meters. No moon in the sky, no seasons because the Earth's axis was perfectly straight up and down, just a monotonous, warm greenhouse. But after that bang, boom, everything changes. Suddenly, we've got a cracked, dynamic surface with deep, dark, crushing ocean basins. We've got distinct, shifting seasons thanks to a new tilt and a beautiful moon lighting up the night sky. So how in the world does a transformation that massive actually happen? Well, we don't need any complex physics formulas here. We can just use an everyday analogy. Think about a pressure cooker, or even better, the champagne bottle principle. You know what happens when you vigorously shake up a sealed bottle of champagne, right? The core engine of the Small Bang Theory is exactly that. Immense pressure slowly building up inside a completely sealed container over a really, really long time. Eventually, that pressure literally has no other choice but to forcefully, violently burst out at the absolutely weakest point. And that is exactly what happened to our Earth. Step 1. About 541 million years ago, the very last volcanoes and gas vents along the equator finally closed up. The Earth completely sealed itself. It's kind of like using modern tire repair spray, As the internal gases and magma tried to escape, they deposited minerals that clogged up the microscopic pores, sealing the crust tighter and tighter. Then, step 2, for the next 475 million years, all those incredibly hot gases from the Earth's core were trapped. They just kept building pressure, until finally, step 3, the inevitable happened. The Earth's granite crust just couldn't take it anymore and violently burst wide open at its thinnest point, right along the equator. Now, to really grasp this, we have to talk about the sheer amount of pressure. We're talking 6,500 bar. That is an absolutely astronomical amount of force. Imagine a continuous, relentless fizzing of trapped gas churning inside the molten magma. That was the engine for this ultimate explosion. Think about 475 million years of chemical outgassing with literally nowhere for that pressure to go. The inside of the Earth essentially became the ultimate pressure cooker, setting the stage perfectly for absolute catastrophe. When that seal finally broke, all hell broke loose, basically overnight. The sudden release of pressure was so incredibly violent that the Earth's actual radius shrank by about 40 kilometers as the crust collapsed inward onto the cooling magma. At the same time, over 1.2% of the Earth's total mass was blasted straight into orbit, clumping together to form our moon. And get this, the explosive torque from that equatorial blast actually knocked the entire planet 23 degrees sideways. Boom, instant seasons. Oh, and that heavy basalt floor that was suddenly exposed under the split crust, that instantly formed our deep ocean basins. A whole cascade of miracles, all from one logical event. Okay, I can already see you raising your hand. You're probably thinking, wait a minute, Professor. If the Earth's small bang happened 66 million years ago and wiped out the dinosaurs, what on earth caused the other 4 global mass extinctions? It's a fantastic question, and the theory has a breathtakingly cosmic answer to this. You see, the small bang isn't just an Earth thing. It's actually a universal planetary life cycle. The truth is way bigger than our planet. Those first four major mass extinctions on Earth, they were actually caused by the small bangs of our neighboring planets. When Uranus popped about 443 million years ago, a massive wave of ice debris hit Earth, causing the Ordovician freeze. Neptune's bang triggered the Devonian extinction. Venus, which is obviously much closer and hotter, rained down this highly toxic, scorching debris during the Permian. Mars had a slightly weaker bang during the Triassic. And that final Cretaceous extinction 66 million years ago, well, that was just our very own homegrown small bang. Now you might be wondering, why didn't the flying debris from Venus or Mars just completely shatter the Earth's sealed granite crust back then? Well, it's because the old Earth was wearing an incredibly thick armor. It had this massive, moist atmosphere, up to 1,000 kilometers thick, with extreme barometric pressure. This dense atmosphere acted like a giant soft cushion. So instead of violent crater-forming asteroid impacts that would crack the shell, the planetary debris was caught softly. But it turned into intense toxic rains, global cooling, and rapid climate shifts, which is what actually drove those earlier extinction waves. Let's fast forward back to our own small bang, 66 million years ago. Where exactly did all that explosive material end up? Well, the vast majority of it, about 98.5%, either stayed put or quickly fell right back down to Earth. About 1.23% stayed up in orbit and coalesced into our moon, and a tiny fraction, just 0.27%, was lost entirely to deep space. But here is the real kicker. That infamous Chicxulub asteroid, the one everyone blames for killing the dinosaurs, according to this theory, it wasn't an alien asteroid at all. It was actually just a gigantic, blown-off chunk of our own granite crust that got launched into brief orbit and then just came crashing back down on us a few months later. Crazy, right? Think of it almost like a butterfly breaking out of a rigid chrysalis to reveal a completely new world. The continents we live on right now, they make up about 29% of the surface, and they are quite literally the broken, floating shards of that ancient 541-million-year-old granite shell. They're just drifting on top of the heavier, exposed basalt underlayer. And that heavy basalt layer is what instantly became the dense, dark floors of our brand new deep ocean basins. And here is where it gets absolutely fascinating from a biological standpoint. For hundreds of millions of years, Earth only had shallow, sunlit, warm swamps. But suddenly, within days or months of the small bang, we had these deep, freezing, pitch-black oceans with crushing pressure. So those bizarre, alien-looking deep-sea creatures we see today, they didn't slowly evolve down there over billions of years. They were actually extreme mutants, kind of like the evolutionary scrap of the shallow lakes that never really fit in during the old world. But suddenly, almost overnight, they found their absolute perfect home in the crushing darkness of the newly formed oceans. Which brings us right back full circle to your very first question. The philosopher Arthur Schopenhauer once hit the nail absolutely on the head when he said, "The task is not so much to see what no one has yet seen, but to think what nobody has yet thought about that which everybody sees." The small bang theory challenges us to take completely familiar anomalies, like how our continents perfectly fit together like puzzle pieces, or how the moon's isotopes match the Earth's exactly, and look at them with completely fresh eyes, without being blinded by centuries of stubborn assumptions. So, I'll leave you with this final, fascinating thought. If a single, logical pressure cooker event from the small bang theory can elegantly explain the creation of our moon, the sudden appearance of our deep oceans, the tilt of our seasons, and the extinction of the dinosaurs all in one fell swoop, what other universal truths are we completely missing out there simply because we refuse to rethink the old rules? Keep that curiosity burning and never, ever stop looking at our incredible blue planet with a sense of wonder.